The Open Geospatial Consortium's Sensor Web-Enablement, or SWE architecture, defines standards that enable interoperable use of networked sensors, including such functions as sensor discovery, tasking, data access, and event detection and notification. These standards describe instrument protocols, web service interfaces, models, and XML encodings. The standards allow users and applications to access instruments and sensor data without needing to know the underlying details of the heterogeneous sensor hardware and platform interfaces. SWE's goal is to expose sensor resources on the web and make them available to distributed applications. Technologies have been developed to achieve this goal and help to manage the heterogeneity of networked sensors. The ultimate goal of these technologies is plug and work. Upon connection to the observatory network, each device should be automatically detected and identified and should provide all the information needed to collect, interpret, and distribute data through standard web services. These technologies take into account the constraints of observatory networks, such as communication interfaces and power limitations. For example, most marine instruments use serial protocols such as RS-232, and only a few use Ethernet. Many marine platforms, such as buoys, gliders, and AUVs, have low bandwidth satellite links to shore and have constrained power resources as well. In this video, we demonstrate several hardware and software components, including an SWE Sensor Observation Service, or SOS, which is based on the 52 North implementation and that conforms to the SOS 2.0 standard. The service provides access to sensors and their data through a standard web interface. The service transfers information with efficient XML interchange format to reduce bandwidth and parsing costs. It implements the SOS transactional and result handling extensions, which allow operations such as insert sensor for publishing new sensors, delete sensor for removing a sensor, insert observation for publishing observations, and insert result for publishing raw values. The sensor platform is built on the Raspberry Pi board and includes software to retrieve metadata from instruments that implement the OGC PUC protocol. The instrument metadata is encoded with efficient XML interchange format and stored within the instrument itself. When the platform detects a new connected instrument, it retrieves and decodes the metadata to obtain the full instrument description, including command protocol and sensor data formats. The platform uses this information to configure the instrument, acquire its sensor data, and transfer the data to the Sensor Observation Service. We demonstrate the system with two instruments, the RBR-CTD and a Nexos hydrophone, both of which implement the OGC PUC protocol and contain appropriate sensor ML in their PUC payloads. In this demo, the two instruments are physically connected to the Raspberry Pi using RS-232 serial ports. The platform software detects each instrument and extracts its sensor ML metadata. The platform then uses the instrument protocol described in the metadata to configure the instrument and begin data acquisition. Finally, the platform sends the acquired instrument sensor data to the Sensor Observation Service using the insert result operation. The SOS stores this data with other measurements from the platform and will provide it to clients upon request. We have demonstrated how several standards at the instrument protocol, platform, and web levels work together, enabling automated integration and configuration of heterogeneous instruments and platforms, as well as uniform network access to the sensor data. This is Tom O'Reilly at the Monterey Bay Aquarium Research Institute.